in the practical execution only.
Good
So,
evening.
good evening. I'm again repeating some basic concepts, that is data structures in R. Uh, I'm sharing again. So, here you can see what we discussed yesterday, that data structures in R are of these types. Number one, vectors, which discussed yesterday, a collection of ordered homogeneous elements, then list heterogeneous elements. Today we will discuss about matrices, arrays, and data frames. It's a revision of yesterday that vectors are the one of the most basic element of data structures now. Even a single object created is also stored in the form of vector. Whatever you create, a complex number, a name, a numeric value, a single character will always be stored in the form of vector in R. Vectors in R programming are the same as arrays in other languages. The indexing of vector will start from 1 and not from 0 as in other languages. Those who are compatible with C, C++, Java, Python, they know that indexing of the element is start. First element is not 0th element, but in R, it is the first element is numbered as first. So it is the code that how we can create vectors. X equals a C is a function that creates vectors of given list. 1, 3, 5, 7, 8, and when we give X on the prompt, it will produce result as that one row of 1, 3, 5, 7, 8 of numbers. Then we discussed list of that date, and we'll do practical of that today. List. Now, R list is the object which contains the elements of different types. Contrary of the vectors, which are of homogeneous type, a list contains elements of different types, like strings, numbers, vectors, and another list inside it. It's a recursive. List in R can be created by placing the sequence inside the list function. Now, how we can create list in R? We will give some example by showing you the console of the R. So, if you are having R installed, you can open it up and will give the commands in R, right? So I will just select this command because I have opened the console for that. Now I am sharing the console to you all. Here you can see it is the R console on which we work. If font are not visible in the YouTube live, I will increase them a bit more. Okay. So here I'll paste the command. That means I'm creating a list of like this. K is assigned to list as a function. First element is example, which is of a string type. Second element is of again a string type. Remember that you have to put inverted commas here for character vectors. Then a vector of three elements. It is the element of list, which is itself is a vector which will be created by three elements 65, 21, and 18. A logical value true, then decimal value 27.2, and then 10.3. Third one. So here are how many elements in this list? Example is the first one, R list. The second one, a vector of 3 elements is the third one, a logical value true is the fourth one, and 27.02 the fifth one, and sixth is very good. The sixth one is 10.3. Now I will put enter. If everything goes well, it will come to the prompt, and when I print that please show me the result, then it will show you that K contains first element as an example, second element is our list, third element is a vector 3 made up of 3 elements, 65, 21, and 80. The fourth element is a Boolean value, which is true. And then fifth element is 27.02, as we discussed. And sixth one is 10.3. So this is how we create lists in R. Here you can see that example and R list, these are the string type variables, whereas these are integer numbers, then a Boolean value. That means what I want to show, that everything in R is possible to create via list. The different type of elements can be stored in a list, where vector stores only a simple type of variable, say either integer or fractions or strings only. They must be all of same type. In case of vectors, they are in other languages we call them array. Okay, have you got this? Now I'll share you a program to create a list. We can also make a program to create list that I'll show you. For this, what you have to do, just watch the presentation I'm showing you here. Now we'll come back to the presentation window, and this is this. So our program to create a list. This is the code. I will explain you. This will contain a vector of first element as employee ID, which is made up of 4 elements. ID will be made up of 1, 2, 3, and 4. There are 4 IDs in this employee list. Then employee name. Name of all employees. These are Debbie, Sandeep, Shubham, and Shiva. The third attribute is number of employees. It is different. It is not made up of 4. It is only simple count of these employees, that is 4. Now we can combine all these 3 with EMP list, which is the name of the list, will be EMP list. Will be list of employee ID, employee name, number of employee. Then we will give command print EMP list. Okay. So let's execute it on our console. Either you can copy or paste the code like this, and it will execute. So what you will find that the first elements of the list are 1, 2, 3, 4. That is employee ID. Second, the elements are the names of employee. 4 employees are there. And third in the list of employee is the total number of employees. So we have first element is made up of 4 numeric elements. Then we have second element, which is made up of 4 name elements, string type. And we have third element, only 1 digit, and that is number of elements, which is 4. Is it visible to all of you?
Yes, sir.
That's very nice.
Yes,
So
sir.
if you are executing it, I can share it, and you can copy paste it also. I think in the message window you can see this code, and you can copy paste if possible. Yes, it's it. Visible to all? See the messages. Select the complete code and copy paste it in a R console or in any file so that later on you can practice it. If you copied, just put reply over here. Very nice. Very nice. So this is how we create list. When we do research in R, we
Sir,
need data. Yes, please go on.
previously, when one was written in the previous numerical, one square bracket was given. Right now, two square brackets. May I know the difference between these?
Yeah. If two square brackets are given, that means a list which is containing of so many elements. One square bracket with another square bracket, it means there are more members in that list. If vector is there, it will print only a single square bracket with one. So in case of vector, you have seen that it prints only one there and after the values. But in case of list, since elements are of different type, it will group them like as. To show you that the different groups are there, it will put double square brackets over there. First group with one row of 1, 2, 3. Second group is of one row with three names, and third group with one single element. Is
Thank
that clear?
Thank you.
Yes. Okay. So further we proceed. You can copy the code. Now we will come to our presentation. That now the number, this contains only a single variable. So a list contains, what I want to show you, that employee ID is made up of integer numbers which are different, employee name which is made up of only string variables, means it contains characters, and number of employees in different in quantity, not in four. They are not for only a single digit that there are four employees. If employees are 5, we can put here 5. If employees are 100, we can put here 100. And then we have given a command print employee list, that it will print the result as you have seen. I am showing here also. I have taken the output for you all. Okay. It is the output screen of previous code which I have shared. That's very nice. Pandyaji has shared the code also. So now we come to another topic, which is matrices. And what is matrix? You all know that matrix is a rectangular arrangement of numbers in rows and columns. Okay. So here in R, matrices are two-dimensional homogeneous data structures. When vectors are combined, they will form matrix. Vectors may be made up of simple type of elements, numerics, fractions, or characters, but all of same type. Remember this. So here you can see that I have put three matrices of different sizes. That first one is of 3 rows and 3 columns. Another one is of single column but 3 rows. A third one that you can see is made up of how many rows and how many columns? Can anybody answer?
One row.
Yes, and 3 columns. There are 3 columns. One row, single row is there. That's very nice. So now let's start with creating matrices. To create list, we use list function, but to create matrix, which is of similar type of elements, we use matrix function, which is I have written here. Suppose Y, I want to create a matrix Y, which is a matrix of column 1, 2, 3, 4, where I will direct put the number of rows and number of columns. That means columns. So you have to tell R that how many rows and how many columns are to be created with the given vector or number of elements. So here we have four elements. We can divide them either 2 by 2 or 4 by 1 or 1 by 4. So it will create matrix. If you have shown R that rows are 2 and columns are 2, then it will create a square matrix of like this. Let's execute this on our console and we will find the result. Okay. I'll again I'll show you the console window. Here it is. And I will put, I think, visible to all, right? I will put enter here. You can see it has created a matrix named Y. When I print Y, it will show like this. That means rows and columns. Now remember, in R, columns are filled first and rows are filled second. So we have given that a vector C, that means a vector of 1, 2, 3, 4. Four elements of vector are there and they are filled like that, one here and two here. Means columns are filled first. That means it is known as column major order. Column major order. So this matrix or any matrix you create in R, by default it is created in the column major order, right? Further, we can create a matrix with this command also, that we can specify at different elements with this. I'll copy paste so that you can see. I must remove this. You can see the code here. First, I'll give the command that Y is a matrix of number of 2 rows and number of 2 columns. I just told the R that create a matrix of 2 rows and 2 columns. Now what R will do, it will create a blank matrix. Okay. Now to give each and every element a value, we can use this command. First row, first column, 1. Then second row, first column, 2. First row, second column, and second row, 4. So it will create a matrix like this. Yes, please. So we can print this, that you can see it again create the same matrix like this. So there are two methods to create matrix. I think the first one is the better one, where you can provide all the elements in a single row of command and then number of rows and number of columns. But since another way is also possible, so I have told you. Now to that, I have told you that they are filled in column major order. Elements are filled in the column major order. I'll give you some more command by which we can tell R that please create matrix by uh, row.
Gayatri, sir, Gayatri has raised the hand. I think she has some doubt.
Yeah, please go on. That's why I have called. Please go on. If you have doubt, please put it on. Hello. Please put your doubt either in the message box or you can open your mic and call it. Are you raising hand for that you have done this or any doubt is there, Gayatri ji? Okay, let's move on. I'll create some one more example for you to understand this. Now, I'm creating a matrix with the elements 1, 2, 3, 4, 5, 6. And I want that number of rows will be 2. It will automatically take the columns because it will be of 2 by 3. There are 6 elements. So rows will be 2, columns will be 3. And by row is true. Here I put T in by row. That means I am telling R that now this time create matrix row wise, not column wise. Okay. So we'll execute this command and we'll find the result like that. I will print M and you will see this that this time 1, 2, 3 are given in the row, 4, 5, 6 in another row. But if what happen if I will not tell that by row order is true, so I will remove that and will execute the command and see the results. I'll remove this by default and execute this and I will print the matrix. Now you can see the difference, both are there. In the second one, you can find that elements are filled in column order, 1 and below that 2 in the same column. Rows are different, 3, 4, 5, 6 in this manner. But here 1, 2, 3 and 4, 5, 6 like this. Okay. Now how to combine matrices? Suppose you have 2 matrices and you want to combine them. So what we can do, I am showing you with the presentation. You can note it down. You can make the diagram as I have created here. You can see this. Combining matrices in R. There are 2 ways of combining matrices in R. Number 1 is column-wise combination and number 2 is row-wise combination. The first one, column-wise combination, how this is possible? It is used by C-bind function. Column bind is a function that combines 2 matrices with column wise. So C bind function. I'm telling you the another function here also, which is R bind. We can combine row wise combination of the matrix. That means R bind function is also there. So we'll discuss that a bit later. First, this one. You can see we have matrix 1, 3, 2, 4. Okay. Here another matrix is 5, 6. When I'll create column wise order, then it will create matrix like this: 1, 2, 3, 4, 5 and 6. That means columns are added. For this, I've created a code here. I'll share you to all. And we will execute together in our console. Here it is, our console. And in the message, I'm giving with the code here. Already I have put. So when you print a matrix which is having one row only of two columns, 1, 2, another matrix of three columns and single row, both are combined with C bind function A comma B, and result will be 1, 2, and another matrix in a column order. That means 3, 4, 5 are added to this matrix. You can put this code for your further revision, and hope you can create the matrices in the combination with 2 rows, 3 rows, and so on. If you have done, please show me the result. Very nice. Again, Pandyaji has put this execution. That's very nice. So this is how we combine the matrices in which order? Column wise order. Now another code I'll share you first on the presentation. I've also recorded the output of the above code that I'm sharing to you. And this is the output you can see of the program. That matrix A having these elements, B is having this element, and after that you can see that C, the combined matrix, is having such elements. Now another function that we will discuss, row wise combination using R bind function. Okay, if you are using R bind function, then column must be of similar length. If you are using C bind function, then row must be of similar length. It should be clear. Otherwise, you can't combine them. So here it is the code for our program for combining two matrices row wise. Again, I am sharing this to all of you. Here it is the code. You can find in the message window. And when you execute this, you will find the following. That means there are two matrices. One is having single row with 1, 2, 3. Second one is having two rows of three columns. And here we can see that columns are of same length, so we can add them row wise. 1, 2, 3, 4, 5, 6, 7, 8. I think that this is pretty clear by this example. If someone has done, please show me the execution in the message. Very nice. So
Excuse me, sir. Can you show us the screen, please? Result screen, sir.
Which one?
Now, sir.
Re-
Yeah,
result.
final screen is showed now.
Yeah, yeah. You can see that. Now again, we come to the presentation screen. I'll show you the result that you will find. I'm sharing results only. Okay. Not the overall output. I'm sharing results only that A matrix will be this, B matrix will be this, and C after combination of all these will be this one. Is that clear to everybody? We are combining these two matrices. These two matrices are combined by which function? R bind, row bind means we are binding rows. This is the first row. We are binding it to second and third row of another matrix. So the overall combination will be first, second, and third. I hope this is clear now. Now we'll come to another thing. Matrix addition and subtraction that we have to practice ourselves. I have not created code here, but we will do it on console, right? So let me share the console. Here it is. So let's create two matrix. Say like this. We'll create a matrix of using the matrix function. That's why I have not created like this. You can see that it gives you help. This is because of you are using R Studio. It shows each and everything which is helpful. So you have to provide data, right? And data I am making of 1, 2, 3, and 4. I'm creating a matrix of element 1, 2, 3, 4. Simple. Then I'll tell that number of rows equals 2. I need not to mention the columns here because it is divisible by 2, so it will create the matrix. You can see there is no error. It had already created the matrix. Okay. Then I will print A for you that 1, 2 having like this, as we know that it fills the column first. So 1, 2, and then 3 and 4 in the second column. Now I'll create another matrix. So that we can identify the result easily. We'll fill simple values. Matrix of column again 1, comma 2, comma 3. This time I am changing the element so that we will find the different kind of results over here. Again, I'm telling the R that it contains two rows. It will automatically divide them into two columns also. So here you will find that B is made up of like this. Now, what I am going to tell you is about how to add two matrices. The corresponding columns and row elements are added to each other. Let's do this. A plus B. As you can see, 1 is added to 1, answer is 2. 2 is added to 2, answer is 4. 3 is added to 3, answer is 6. And you can see I have put the different element in last one, which is 5 and 4 adds 9, so that we can find the results. Similarly, we can subtract these matrices like this: A minus B. So you can see the result: 1 minus 1, 0, 2 minus 2, 0, 3 minus 3, 0, and 5 minus 6 gives minus 1. I hope that is pretty clear. So it is the simple addition and subtraction of matrices. Now we'll come to another thing. Let me show you via the presentation. I am giving you this assignment so that you can do it yourself. You can create matrix of same size, same length, and then add them and subtract them. Now come to another topic, and that is I'm showing you matrix multiplication, which is a bit different, and science will members, they know that. Matrix multiplication, we can multiply two matrices A and B of size M cross N and N cross P, means number of rows and number of columns. Here N is equal to N, means number of columns of second matrix must be equal to number of rows of first matrix. The resulting matrix will have the size of M cross P. That means N will cancel N and the resultant matrix will have M cross P. So how we'll find that matrices are having the order to multiply, or otherwise it will give you the wrong output or error. So there is a dim function in R which gives you the order of the matrix. That means how many rows and columns it will have. Now let's go to the console and use them. So I'm putting here dim. If you remember that we have created a matrix M. So dimension of M, that means orders of M are 2 rows and 3 columns. How? Here you can see there are 2 rows and 3 columns. Clear? Now I'll print dim of F. It will be of 2 by 2. Dim of B, which we have created of similar type, having 2 by 2. So we can multiply these two matrices because matrix A having number of column is equal to matrix B number of rows. The resultant matrix having 2 by 2 elements. That means 4 elements again. I will not go into the details of matrix multiplication because it is a totally mathematical interpretation which science students and science scholars know. So I will just give you the output because it is a part of our learning process. So you must know that when we create matrix, there is an operation of matrix multiplication. So how to do matrix multiplication? Not by star operator. So what to do for matrix multiplication? We have to use percent star percent. Let me show you. A percent star, then again a percent sign. You can see it had turned to blue again. B. Now let's see what happens. It will give you the result of multiplication, which is totally different. I am printing A and B here. There are two matrices, and the result is already there above. You can see that it is not just multiplication of 1 into 1, 2 into 2, 3 into 3, or 5 into 4. It is not just the multiplication of the members. It is totally different thing, but we have to share it over here. Some more operation on matrices. Matrix transpose. If you have stored your data in matrix and you want to transpose them, that means if a matrix is made up of rows and columns, row will be converted to columns and vice versa, and columns will be converted to rows. So how we'll do that? There is a function T in R by which we can create transpose of any matrix. So you can see here that a matrix is already there, 1, 2, 3, and 1 and 2. These are the rows and these are the columns. So matrix is 2, 5, 2, 6, 1, 4. Now, when we use TA function on the matrix, the rows will be converted to columns and columns are converted to rows. So 2, 6, 5, 1, and then 2 and 4. Here it is. So let's do it on our console also. We have a matrix M. You already know. I'm printing here. To find the transpose, we will use T of M, transpose of M. And you can see 1, 3, 5, 2, 4, 6 is now converted to 1, 2, 3, 4, 5, 6. So I hope this is clear, transpose function. Then another operation will come to arrays. Since arrays is not too much usable in research, we just discuss as because it is a part of data structure in which data are stored. So I'll showing you only the basics, but we'll come to data frames which are very useful in our R. Here you can see what are arrays. Arrays in R store the similar types of data for processing. Actually, vectors are also arrays. Arrays can be one of the multiple dimensions. Vectors are type of array, but array is something more. That means it can be of multiple dimensions. Let's see. The arrays created using vectors is of one dimension, is known as one-dimensional array. Whatever vector you are creating in R is a unidimensional or one-dimensional array. Similarly, matrices in R language are considered as two-dimensional array. The matrices right now we are using having two dimensions, rows and columns. There is another thing, a three-dimensional array is also possible. in R. So how we can create them? Let's see. Here we can see a one-dimensional array is a vector only. You just give elements by C function, and vector 1 will be called one-dimensional array. So all vectors are one-dimensional array. Multi-dimensional array, in which first one are matrices which are two-dimensional. A two-dimensional matrix is an array specified by a fixed number of rows and columns, each containing of same data type. A matrix is created by using array function to which values and the dimensions are passed. So we can also use array function to create array of multi-dimension. Let's see how. Here it is. Suppose I have created a vector x equal to 2 is to 30. It's yesterday in vector class we have seen that from 2 to 13 can be written with slice operator to slice 13. Means from starting from 2 up to 13, create a vector of elements. So it will create the vector of 2, 3, 4, 5, 6, 7 up to 13. So let's do it on our console. Here it is. So we want to create a vector which is having the elements from 2 to 13 as I have discussed. So what we type here, x equals from 2 up to 13. This is known as slice operator. When I print x, it will give you 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yesterday we discussed it. Now I want to create array of multi-dimension by this vector. So how to proceed? Here it is a command. I'll create an array ARR with name ARR. So how? I'll put the command over here. You can see this. ARR, that means create array of AR name ARR, which is used by function array. Which data has to be used? X. X is the vector by which I am creating an array, multi-dimensional array, 2 by 3 columns and 2 of 2 by 3 columns array. What I want to say, there will be a matrix of 2 rows and 3 columns, and such type of 2 matrices will be there. I think it is clear. So it will create matrix of 2, 3, 4, 5, 6, 7, 1, and second matrix 8, 9, 10, 11, 12, 13 of second. That means matrix of 2 rows, 3 columns, and there will be 2 matrices. This is the meaning of this dimension. Dimension having 2, 3, 2. Remember to put C and bracket here so that we can create the elements in this manner. So let's do it. You can see it has created an ARR array. I will print that and you will see the result. First one is comma, comma, 1. That means a first matrix of 2 rows and 3 columns will be, you can see 2, 3, 4. As you know that we haven't specified here row major order, so elements will be filled column wise. So 2, 3 in the column, the next column will be 4, 5, then 6, 7. Here you can see from first 6 elements. And another 6 elements, you can see 8, 9, 10, 11, and 12, 13. So 3 2s are 6, 2s are 12. That means there should be 12 elements that we can divide in two matrices of 2 rows, 3 columns. So this is an array. An array is made up of matrices. So it is another type of data structure that R supports. Is anybody having doubt in this? Please ask.
So till now we discussed many operations like transpose, arrays and all. Where do we
Yes,
execute these operations in our day-to-day life or in our research papers?
very nice. Yesterday I have told you that these are the basic operations that you must know, because when you will open the research methodology or research programming, if you will find some program in any text, then you will be able to understand that which operation has been performed on that, right? So that's why we must know the basic operation. Suppose in some text you find that there will be an operation, data is stored in two matrices, and they have taken the multiplication of two matrices for any purpose, for any result. Then how will you understand that? Just because you are not having the basic elements of that. So we must discuss the operations, because suppose a data you have taken in row wise. Now you want to change it in column wise for your printing format. Then how will you do? Then you have to take transpose of that, right? So these are the basic things that you gradually learn. Since we are in the learning phase, we'll use it in day by day practice as you will be comfortable with them.
Okay, thank you, sir.
Most welcome. So thank you. Anybody else? Pandyaji, have you executed? Very
Yes, sir.
nice. You are very prompt. You have already executed on system. Thank
Yes,
you
sir.
so much for informing. That's nice. Now, because a session must be interactive, I'm only speaking and people are not responding. That means they are not getting either, or they are not having notebooks right now. But at least they can understand the basic concepts. If they are getting that, it's fruitful. Then I will come to another thing. I'll show you. We'll come to our presentation. And since you have the this session recorded and now it is clear, so clearly visible, so you can use it for your demonstration also or your future learning. Here it is. I have shown you that how we use arrays and how we create arrays of different matrices or different data sets. Here it is. That output I have already recorded on this screen. Now, the very important part of the data structure, you must learn it very properly, which is data frames. In everyday life, you will be recording the names of the peoples for your data. You will be recording their responses. You will be recording their outcomes of the responses. You must know which type of data you are going to use for characters, names. For example, to store names, you must know that you will be able to use character data types. Then for numeric values, you will be able to use numeric data types. That means fractional values. And for true and false can be used for yes and no. If somebody says yes, you can record it as true, and if somebody says false, that you sorry, no, then you can record it as false. So these boolean variables are also useful. Now what is a data frame? To record all such different type of data in listed and record manner, we use data frames in our R. This is where the research begins. Okay, you have already learned about the different type of data structures in R available. Now we are discussing about data frames, which is the basic data structure that we'll use in all our data analysis. So be very keen about this. Data frames in R language are generic data objects of R which are used to store tabular data. What you do in research, you create tabular data, right? Data frame is made up of three principal components like data, rows, and columns. What I'm telling you, that every data frame is made up of, in R, data frame is made up of data, rows, and columns. A row means a single record that you can see. I have taken a screenshot from net, so you can see that every Bradley, Boston Celtics, number 0 0.0, position PG, age 25. It's a single record having the record number 0. Then record number 1 having John Holland, Boston Celtics, and then 30.0 the numbers, SG, position, and 27.0. It is the age. So these are the records of peoples, and you can see the different type of data we are using here. For name, we are using character data type. For team, we are using character data type. For number, we are using points, fractional numbers. For position, we are using 2 letters in capitals. And for age, here NAN is been specified that they don't know, not available. So NAN, not available data is known as NAN, not available. Then here we can say that rows are having numbers 0, 1, 2, 3, 4, 5, 6, which are numeric again, but integer. It can't have points. So this is a data frame in picture. But how it is stored in R, let's see that. Here, it is a program to create data frame in R. We use data.frame command. Remember, data.frame command is used to create data frames. I'm putting the code over here. We are going to create a data of players. Let me first explain it how we are doing. Our program to create data frame of players. Player.data is the name of the frame that R is going to store by player.data name of the data frame. Then data frame is a function. Since it is in so many lines, I have broken up bracket PID means ID of the player. Name of that column is PID. Then C means it's a vector, which is the sequence of from 10 up to 50 by 10. Yesterday, we have used sequence command. I'm using over here so that you will be able to learn it. So suppose in a sequence you want to create from 100 to 500. There are 5 numbers you want to create: 100, 200, 300, 500. Then what you can do? You can write 100, 500 by 100. Is that clear?
Yes, sir.
Okay. So here player ID is made up of 2 digits, and there will be 5 players. First ID will be 10, second ID will be 20, third ID will be 30, fourth ID will be 40, and last one player, fifth player, will be having the ID 50. Okay. Now player name is again a vector of C. Sachin, Saurabh, Dravid, Sehwag, and Dhoni. So by giving this command, it will create a data frame, a tabular data of which is having PID, first column, a second ID, P name, name of the player. Now we will use the command to print the data frame as print player.data. So let me share you this code also, and I'll execute it on our console also. So let's go to our R console. Here, here is our R console. You can see. I'm putting code here. If there are dots that I have removed. I'll put enter so that yes. Now I am sharing you all this code. You can save it for your future reference. So what we are doing with this? Here you can see in the console our program to create data frame of players. That means it is a comment line. It it is not meant to be for computers. It is only for our understanding. Computer will not do anything for this. Computer will take action from this that player.data will be created by data frame of bracket. Here, when you put this command incomplete, R will show a plus sign. You can see. Here it is plus sign because command is not complete. PID, which is a vector of sequence 10 up to 50 by difference of 10, comma, P name equals to vector of all player names Sachin, Saurav, Dravid, Sehwag, and Dhoni. And when you will execute this command and print the player data, it will show you like this on screen. If you have executed, please put your code also here from screen. Very nice. So now you can see we are gradually coming to that stage from where the research begins. In research, you collect data, and from that data, you create statistics, and from that statistics, you reach to some results, right? So it is the first step from R towards data analysis. Now, since you have created the data frame, I'll show you other operations. Here, you can see I have recorded the output for you all so that it would be able to share you at the time of power failure. Now, we can use dollar operator, which is known as member operator. We can use dollar operator to access columns of data frame. Suppose you want to extract data for your future reference or for any calculation. Suppose you want to take all the ages of player or all the IDs of player to find average, to find mean, to find mod, then you can use the dollar operator with the data frame data name. Let's do this on our console. So here it is console. You can see that again I'm printing the player.data by direct command. You just press enter because it is in the IDE. Whenever you write data names, it will show you the suggestions, and you can select it by enter. Press enter, you will see that player.data contains a data frame of PID and name. 1, 2, 3, 4, 5 is automatically the row numbers of that data frame, which are generated by our default. Now, I just want to print only the IDs. I want to extract the IDs, or I just want to use the IDs of player name. Suppose I want to take average. Suppose I want to calculate the mean. There may be one more column that we can add further, age, right? So how we will do that, we will discuss that later on. But first thing, how to access the columns. So let's print player dot data dollar, use dollar sign, and you can see that R is already this R studio. Remember, this R studio is showing you what you can use with player data with dollar. You can take the members either PID or P name. You press enter to print PID. So you can see that is a vector of 5 elements: 10, 20, 30, 40, and 50. Now again, I want to print only the name. I want to use the name only for my purpose. So what I can use, I will do the same thing. I'll use the dollar sign and ask R to tell me what are the names. You can see that it is already showing you the output. What will the output will be? Press enter and it will show you the results. That Sachin, Saurabh, Dravid, Sehwag, and Dhoni. These are the player names. Is that clear to everybody? That dollar sign is used to create the column names. We can access the columns by using dollar sign. Clear?
Yes, sir.
Okay. Thank you for confirming. Now, we'll add some columns to data frame. Suppose I have done already something for you, and I'll show you. Adding components. Rows can be added to a data frame using the rbind function. Suppose I want to add name Rinku in our player list. So what I can use this one, rbind, to bind a new row to our data frame. Let's say this. I'll copy it and I will execute in R console. Those who are doing practice, you can just type, I am pasting here that I have already done, and this for you. You can write it down. Player.data, add a new row of data. How? Player.data equal to rbind player.data, name of the data frame in which you want to bind the new row. Then use command list, a new list of record. There are only two things. One is number, that is 60 will be the next number, comma, the name of the player you want to add. I am using Rinku. So by executing this command, you can see that it will add new row into the data frame, which is the player data. To see the result, we can use here. You can see player.data command. I am giving it onto the console to print the list, and it is like this. Here you can see the sixth row is added with The data I have given 60 and name is Rinku. So this is how we can add data into data frame. This was adding a new row. That means a new record of a new player. Suppose you want to add some new column inside the frame, then what we can do, let's see this. Yeah, conflict. Visible to you? That slide is visible or not?
Sir, the screen is frozen.
Okay. I don't know what happened. It is already showing that it is sharing. I don't know what is the technical glitch in this, but uh, you'll try once more. Yeah, now it is showing me the screen actually that it can't share a screen. We should report it to Google. Yeah, now it's back again. Thank God. This is the part that we have covered, that using the R bind in the
Sir, are you
I don't know what kind of technical glitch is there. So let's again share the screen. It may be some kind of network issue. Google is showing me some error, but I'll do again. Yeah, you can see again. We have done up to this that in R bind we can use player data, which is the name of data frame in which you want to add the elements. Then list 60 and Rinku, these are the data values which we want to add. Okay. Now we'll come to another thing that if I want to add column, then I can use cbind function. Here, I'll show you that how we can use this. A player dot data will be equal to cbind player dot data. That means a previous data, comma code. Code means the name of the column that you want to add. Then column C with code SA, SO, DR, SH, DH, RN. These are the player name code actually. For Sachin, I have taken SA. For Sora, I have taken SO. For Dravid, I have taken DR. For Sehwag, I have taken SH. Then for Dhoni, I have taken DH. And for Rinku, I have taken RN. This will show you this output. Let's do this and hope that Google will allow me to share a screen also. Now this is our data frame. Again, I'm tapping this. I'm pasting the code player.data. Here we have to use cbind function. It is not copied, so I will take that step again and I'll show you. Here it is the cbind function, which I will put on the console to show you. We have to use like that, player dot data equals. I hope you will be able to see the whole line. Is that visible to you?
Yes, yes, please.
Player dot data equal to cbind previous player of data, then code C, SA, SO, DR, SS, DH, RN, whatever you want to give the code to the players, we have written here. Now I'll put enter and you will see that it has taken the command, executed. Now I'll print using player dot data and it will show me that one row, one column of code is added to this. We already have added row to that, but this time we are adding column. So this is how you can add row and column to your data frame once you have created that. Right? Any queries regarding data frames right now, till now?
C bind, there C is vector, sir. Code
Yes.
code is equal to C. There C stands for code. Two different C's.
Yes. See, bind means you have to bind a column inside the new data frame. This is a column. You can see SA, SO, DR, SH. We are binding a new column. That means suppose we want to take age, then we can write here age. Age equals to. Let's do that practically. Age. Sorry. Here I am taking this command once again. And now what I'm going to show you live with this, that I'm going to add age. Again, a fourth column with number values. I'll delete all these and I will make ages of the players random. I don't know actual ages. I'm putting only the random values. Have we done with 6 values? Yes. Let's see. It will create one more column with cbind function. Cbind stands for the column, and here C means a vector of that much value. Where we want to create a vector, we will use C function. So you are creating a column vector with values this. So we are using age. Age is the name of that column, and the column C is itself a vector of 34, 45, 43, 42, 40, 32. Let's do it. Yes, it's perfectly executable. Then I will use player dot data, and you can see now I am having 4 columns. You can see I am having 4 columns. Now, suppose I want to delete some column from this. So how we can? Let's see. I'm showing you the presentation. You can see this. There is how we can delete columns. What kind of data you want to remove? You can use delete columns can be done by assigning null to it. If you want to delete any column, what you can do, you just put the member equals to null, pointed to null. This is the pointer operation that we have discussed. It is leftward assignment. So player.data $code is null. Let's execute this on our console to delete the code column, right? Here you can see that we have this data frame. Now I want to delete the code column. So what I can do, I should use player dot data, and I will put the $sign over here. Then what column I want to delete, I'll select that equals to, in capital you have to write null. Okay. Now since we are using R Studio, it will show that we are using null. That means nothing. You have to drop that. Yes, please. So I am selecting null, and now player.data and $code equal to null. What it means, it is same as, okay, let me remove the confusion. In the older version of R, we will use like that. And in new version of R, we'll use the above command. So now I will print player.data, and you will see that the code column has been deleted, right? So this is how we delete a complete column from a data frame. Now I'll show you the next step, and that would be the last thing of today's class session. Save data frame. Suppose you have created a large amount of data, means you have created today 50 records. Now you want to save them. How you can save them in R? There are two ways: in a file, or if you are using R, then you can save the environment whenever you exit, when you close the R window. Here, to separately save this file into RDA, you can use RDA file to store data frame. So let me show you that. Suppose we want to save our player data into file name pfile.rda. So how we can do that? You know that in Word and PowerPoint, these inverted commas are changes to some symbols. So we have to change that, otherwise it will give you errors. So again, we'll come to our console to show you that in our R studio, we want to save this player data into a file, RDA file. Okay. Remember that this inverted comma has been changed by word. It is pre-processed into some symbol of inverted comma. We want to use this one actually. Now you can see the difference. It is converted to blue. Now save. What is the command to save into the R data file? Save player.data is the name of data frame you are going to save. The data you have taken for your research purposes that you have created, that this player data that we have created, player.data, comma, file. Which file? Equals to pfile.rda. Remember this, or you can note it down for your future reference so that you will be able to save your data into separate file. Now I am pressing enter and you can see that R is saving my data into a file which is pfile.rda. Suppose after some time or some days we want to use that data, then how we can proceed? For this we can use load command, load bracket and then file. Then equals to sign, right? Then name of that file, you must remember the name of that file. So here we can say that we have saved p file. Yes,
pfile.rda.
very nice. P file.rda. You can see that load file equal to p file.rda, and when you press enter, it will load all the data you have previously saved. So in player.data, here it is. So this was all about lists, then matrices, arrays, and most important, from all such data types, we have created data frames, which is very first step towards data analysis. So we have covered that today. I hope the session was interacting, and thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Pandyaji has given the code also. Have a nice evening.
Same to you.
Thank you, sir.
Most welcome. Tomorrow at the same time, 6 p.m., we'll meet again with our fourth day of the session. Thank you so much, everyone, for cooperating.